Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Let me know that sound quality, picture quality, everything is fine. Yes, please. Now guys, join the session because we are going to discuss what simple diode circuit from analog. Okay, and in last class I have given you the idea about basics of analog, where we have discussed the concepts of diode, forward bias diode and reverse bias diode under ideal condition and under practical condition. Okay, let me know that sound quality, picture quality, everything is fine. Yes, please. Okay then. Now this is a analog plus network per digital, that is the super 3 subject series by me, and here we are going to discuss what simple diode circuits. This session is important for what? Electronics student, electrical students and instrumentation branch. So Shailaja, how are you? Very good evening everyone. Now this is a GATE 2024 summer special series and this is my introduction. Myself Sanjay Rathi. I am having around 22 years of teaching experience and I have qualified and selected for engineering services exam. These are my ranks, AIR 16 and AIR 21, and I have trained more than 1 lakh students for these competitive exams. Remember guys, what about the analog? Analog is highly interesting subject, right? Application based subject. No need to mug up the concept, try to understand the concept. एक बार अगर आपको concept आ गया, then it will become very easy to solve the questions on from the analog subject. Okay, so what is the sequence? In last class I have given you the sequence. First of all, get the command over the diode circuits, then what? BJT, then MOSFET, and then what? Remaining topics like oscillators, feedback amplifier, multi-stage amplifier, and finally operational amplifier and linear wave shaping circuits. Okay, now we are going to start one important series, that is BYJU'S Premier League BPL for electrical, electronics and computer science branch on YouTube and app series is starting soon. Then subscribe our channel so that you will get the notification about this session. And if you want to start your GATE preparations right with us, then you have the golden opportunity. Give national scholarship test for GATE examination and get up to 90% off on our program. What is the date? 25th June, means this Sunday at 9 AM. You can register for this now. Okay, it is a free scholarship test and you will avail 90% off. And if you want to get strategy to be in top 1% in GATE 2024, you want to get the idea about the GATE examination, then free live interactive workshop by Richa Gupta ma'am, right? Okay, and what is the date? 27th June at 7:30 PM, means on Tuesday, coming Tuesday. Note the time and register yourself for this. CSE, which should I in first year? You can start with the maths and aptitude. Indian bowler, I give you the idea about that. Okay. Now guys, that is the first question. They are very basic questions. We will start with the very basic one and try to give me the answer for this question. And then diode circuit. Diode, remember guys, diode is a very important topic from the analog. Today we will solve simple diode circuit questions. And remember guys, I am going to take one previous year question series. Tomorrow we will discuss what digital, right? And then questions from the digital, basics of the digital, then questions from the digital, then previous year questions of digital, analog and what? Network. We will discuss. Okay. Then tell me, if the forward bias diode voltage VD is 0.7 volt, find the diode current ID. Find the diode current ID. What is the value of the diode current ID, everyone? What is the ID here? Now this 15 volt is connected here, 10 kilo ohm is connected here, 20 kilo ohm is connected here, 20 kilo ohm is connected here. If it is a practical diode, so yesterday I have given you the hint that in this case choose the 0.7 volt, then Okay. You can replace the diode by its voltage 0.7 volt. Now, this is converted into a battery, and what is the value of the battery? Only 0.7 volt. Then you can apply nodal analysis at this point, or you can also apply the mesh analysis. So what is the diagram actually? This diagram, we can convert the diagram like this. This battery 15 volt. It is the 15 volt. This resistor is connected as 10 kilo ohm. This is the 15 volt, that is the second point is connected to ground, then 10 kilo ohm, then this is connected 20 kilo ohm, and this is the VA. I'm talking about this VA. 20 kilo ohm to ground, and here from A to ground 0.7 volt battery, and we are having 20 kilo ohm resistor here. 20 kilo ohm resistor here, and you have to find the current here through this diagram, 0.7 volt. So that is the diagram. First of all, redraw the diagram, right? Then it is a very easy question. This is the 15 volt battery. What about the second point? Second point is connected to ground actually. This is the 15 volt battery, then 10 kilo ohm, then this is the case. So now you can apply what mesh analysis, or you can apply any other method, right? For example, you want to find with the what nodal analysis, then you can write the node at this point, VA minus 15 divided by 10 plus VA minus 0 divided by 20 plus VA minus 0.7 divided by 20, that will become 0. Just find the value of the VA. So you can take 20 as a LCM. It will become 2 VA minus 30 plus VA minus 0.7, that is equal to what? 0. This 20 will become 0. 2 plus 3 plus 4 VA is equal to 30.7. So 4 VA is equal to 30.7. So what is the VA is equal to? 30.7 divided by 4 volt. Now once you have the VA, means voltage at this point, this is the 0.7 volt battery. What is the current through the diode? VA minus 0.7 upon 20 kilo ohm. VA minus 0.7, that is the drop, and 20 kilo ohm. Put the value. Divided by 20, and you will get the answer for this question. What is the answer then? What is the answer, guys? Yes, please. I think more than one, right? Okay. Sorry. This is the 4 into 20, 80. That is the yes. You are going to please calculate it, and this is the way. So I am just giving you the hint, guys. So this is the method to solve the questions. You will start the test series for ISRO or not? Rahul Saini. It's not. I have given your feedback to our team, guys. Give me one date, because tomorrow, day after tomorrow, we have engineering services mains examination. Yes, on 25th June, we have engineering services mains this Sunday. Okay, so we are just communicating with the students for engineering services mains, and on that same day, you will get the idea. Okay, then that is the answer. So this is the first question. So in any competitive exams, you will get this type of questions. So try to solve this one. This is a simple diode circuit. Now, ready to solve the second question, guys? Okay. So what is the second question here? Now I'm going to give you the second question. This one. Tell me. This is the second question. Okay. This is a MSQ, multiple select question. The value of I and V in the following circuit. What is the value of I and what is the value of V here? I and V. Remember, guys, if nothing is given, silicon diode, it is not given. What is the drop across the diode? It is not given. Then you have to assume what? You have to assume ideal diodes. What, Nandita, what you want, what you are asking about which class? Then this is the ideal diode if nothing is given. Okay, so both the diodes are ideal. Now, what is asked here? It is MSQ. Then you have to find the V. Then you have to find the D1. So there are two diodes. So how many cases? How many cases, guys? D1 and D2. There are 4 cases. Both off, off on off, and both on. So there are 4 cases, guys. Now with the practice, you have to judge which options are correct. So sometimes in a first attempt it may be correct, or in a second attempt it may be correct. Now try to understand. This particular diode is forward biased by the 10 volt because it is a 10 volt. Here we are having the 10 volt and that diode is forward biased. Now we can assume that this is the diode is forward biased. Okay. Then what about this diode? This is the on negative terminal we are having the minus 10 volt. In case of diode, if we are having the negative voltage on the negative terminal, then again it may be the forward bias. So when we are giving the first look, then that it seems that both the diodes are forward bias. How? Because of this 10 volt it is forward bias. Because of this minus 10 volt on the negative terminal, it may be the forward bias. If suppose we are assuming that both the diodes are forward bias. I am assuming. Just I am giving you the hint how to solve the questions. Okay. Because it is visible in the diagram, D1 and D2 are forward bias. Means they act as what? Act as short circuit. Okay, this is our assumptions. Now if it is act as short circuit, try to understand. If it will act as short circuit, guys, means that is connected to ground. This is also short circuit, that is connected to ground, and the V will become 0. V will become 0. Now we will check. This diode acts as short circuit. This diode acts as short circuit. This point is connected to ground, and that's why this V will become 0. Okay. Now this is the 5 kilo ohm resistor, minus 10 volt, and this is the 5 kilo ohm. Okay, and this is the 10 kilo ohm. Now try to understand what is the current here. What is the current? Because this voltage is 0. So you can find the current 10 minus 10 divided by that 1 milliampere. This 1 milliampere current will flow through diode D2. Yes, from P to N side. That is the correct, because the current will flow from P side to N side. That is what is the current? 1 milliampere. Now, what is the current from this point to this point? If this voltage is 0, what is the current here? 0 minus of minus 10 divided by 5. So what is the current here? 2 milliampere. What is the current here? 2 milliampere. And what is the current here? 1 milliampere. Then what is the current here, guys? What is the current through the diode D1? So you can apply the KCL at this point. What are the incoming current? ID1 and ID2. And what is the outgoing current? 2 milliampere. Incoming current ID1 plus ID2 is equal to outgoing current, that is 0 minus of minus 10 upon what? 5. That is nothing but 2 milliampere. So ID2 you have idea 1 milliampere, ID2, and you have to find the ID1. That will become 2. So what is the ID1? 2 minus 1, that is 1 milliampere. The current through this diode is 1 milliampere, guys. So if the current through this diode is 1 milliampere, so which answer? I am not getting any answer. That all the conditions are satisfied. Tell me. All the conditions are satisfied. Yes. Okay, sir, I have doubt in the BJT AC analysis. Okay, I will take the session on that. Now tell me, guys, my assumptions is correct, or is there any problem in this question? Tell me. So leave the answer. Think about this. 10 divided by 10, it will give 1 milliampere current, right? And what will be the current through the diode? 1 milliampere. Yes, it will allow the 1 milliampere current in the positive to negative direction. This is 0, this is 0, and that's why what is the current here? 2 milliampere. And then, guys, you can say 1 milliampere from this point and 1 milliampere from this point, and total current will become 2 milliampere. And that is the correct. Okay. Both the diodes are what? On. And what is the output voltage? 0. Okay. Now, suppose I am changing the value. Just I am giving you the hint. This is the 5 kilo ohm. This is the 5 kilo ohm. and this is the 10 kilo ohm. Now please check the answer. This is the 10 kilo ohm, this is the 5 kilo ohm. Then what is the result? Let both the diodes are on. Again, let D1 and D2 are on. Now in this case, if we are assuming that D1 and D2 are on, guys, D1 and D2 both are on, then again the voltage at this point is 0. That's why this voltage is 0, V is 0. Both the diode will act as short circuit. That's why V is 0. Now what is the current here? The current here will become 10 minus 0 upon 5. So that is the 2 milliampere. Okay. And what is the current here? 0 minus of minus 10 divided by 10, 1 milliampere. Now when we are applying the KCL at this point, what is the incoming current I? What is the incoming current I? What are the incoming current plus 2 milliampere? I plus 2. And what is the outgoing current? 1. What is the value of the I? Minus 2 plus 1, that is the minus 1 milliampere. But remember, that diode will not allow the negative current. If the diode will not allow the negative current, means our assumptions is wrong. In second case, when we are changing the value of the resistance here, 5 kilo ohm and 10 kilo ohm. Now our assumptions is that diode is not forward bias, and therefore this is wrong. Our assumptions is wrong. You have to check. If your assumptions is wrong, means what is the condition? Because it will not allow the current in reverse direction. That's why D1 is off, let D2 is on. So second condition. With new condition, that is the 10 kilo ohm and this is the 5 kilo ohm. Now let D1 off, D2 on. If the D1 on, D2 on, this is off, remove it. Then what will be the current? Current will become 0. This diode will act as short circuit. 10 kilo ohm, this is the minus 10 volt. And this diode will act as open circuit. Remove this diode. This is connected to ground. This is the D2. This is the 5 kilo ohm. This is the 10 volt. Now what is the voltage at this point? You can apply the KCL V minus 10 upon 5 plus V minus of minus 10 upon 10. That is equal to 0. You can take 10 as LCM. It will become 2V minus 20 plus V plus 10 is equal to 0. Then it will become 3V is equal to what? 10. And what is the V then? 10 by 3. That is the 3.33. Okay. Means what is the problem in the question? There is a simple problem in the question, guys. We have changed the value of the resistance, guys. So means this is the question with 5 kilo ohm here, 10 kilo ohm here. If suppose I am giving this question, then what is the answer? I is equal to 0 and what? V is equal to 3.3. Okay, that is the question. But if this is the question 10 kilo ohm here, 5 kilo ohm here, then just simply we are changing the value of the resistance. The diode D1 is on, diode D2 is also on. Both are on and V will become 0. And what is the current through the diode? It will become 1 milliampere. Tell me, guys, is there any doubt? So there are two cases. We are simply changing the value of the resistance and the question will change. So don't think that we are getting the same situation. In both the cases, we are having the two different situations. In one case, both the diodes are on. In another case, D1 is off, D2 is on. This is the answer. So this is the case 1. 10 kilo ohm, 5 kilo ohm. This is on, this is on. This is the case 2. 5 kilo ohm, 10 kilo ohm. And in that case, we have proved that our assumptions is wrong. And then this is off, this is on. Okay, tell me, guys, if you have any doubts, then please ask me. Next question. Ready for next question? Your comments are not visible. Well, give me 1 minute. Yes. Okay, the next one, Lokesh. Okay, you are Acha Nandita, you are asking about the analog. I think after few days. Then this is the 10 1 kilo ohm, this is the diode. The IV characteristics of the diode in the circuit given below. Sometimes they will give you the IV characteristics. Okay, I want to ask one question. How many students attended my previous session on the basics of the analog? Basics of analog. Yesterday I have taken one session. Basics of analog, where I have given you the piecewise linear model of diode. Piecewise linear model of the diode. So here we are going to use that piecewise linear model of the diode. This is the diode. It is a practical diode because its current is given, and that is called the cut-in voltage. That is called the cut-in voltage. If the cut-in voltage is less than 0.7, the current is 0. If the cut-in voltage is greater than 0.7, then this is the equation of the current through the diode. And what is the V here? V is the voltage across the diode. Then what is the current in the circuit? That is the question. It is a practical diode. How we can solve this question? This V and I are not independent. They depend on each other according to this equation. I is equal to V minus 0.7 upon 500. Now guys, we are applying the 10 volt. If suppose we are assuming that it is off, then what is the current? 0. Then what is the drop across the diode? There will be the two cases. Let the diode is off. When I am assuming the diode is off, what is the current? 0. So what is the drop across the diode? It will act as open circuit, and the drop will become 10 volt, and 10 volt is greater than 0.7 volt. Therefore, this assumption is wrong. It is not off. This diode is what? On. This diode is on, and it will satisfy the first condition. It will satisfy the first condition because the voltage across the diode is greater than 0.7 volt when we are checking it. Okay, then, okay, the next is, so according to the next case, now the diode is on. Okay, if the diode is on, it will follow this formula, V minus 0.7 upon 500 ampere. What is the resistance in kilo ohm? So why we can't convert it into milliampere? Yes, we can convert. V minus 0.7 upon 500 ampere multiplied with the 1000, it is converted into milliampere. So what is the milliampere? 500, that will become 2, and it will become what? 2V minus 1.4. Now this is the current in milliampere. I is equal to 2V minus 1.4, that is converted into milliampere because resistance in kilo ohm. Now you have one equation, one relation between V and I, that is 2V minus 1.4. Now we have two unknowns, I and V. So what is the second equation from the diagram? What is the I is equal to 10 minus V divided by 1 kilo ohm. 10 minus V divided by 1 kilo ohm, that is nothing but 10 minus V. 10 minus V divided by 1, that is the 10 minus V. Now you have to find the I. Then simply, what is the V? What is the V from this formula? You will get V is equal to 10 minus I. Put this equation in first one. So what is the I is equal to 2 times of 10 minus I minus 1.4. And what is this? I is equal to 20 minus 2I minus 1.4. Then it will become 3I is equal to 20 minus 1.4. What is the 20 minus 1.4? 18.6 divided by 3. And I will become 18.6 divided by 3, that is nothing but 6.2 milliampere. 6.2 milliampere. Okay. Right. So what is the answer for this question? 6.2 milliampere means this is the answer. Which one? D. There are different ways to solve the question. There are different ways. This is the first way. And I am giving you the second method. Right? I am giving you the second method, guys. So that is the first way. So what is the very, very easy one? No need to write diagram. Simply, there are two unknowns. I and V are depend on each other. Diode is forward bias. One equation we are getting from this, directly convert it into milliampere. Second equation, you can take the diagram, 10 minus V divided by 1. Two unknowns, two values, you have to find the I. That's why directly convert it into terms of I and you will get the answer 6.2 milliampere. Okay. Now tell me, what is the drop across the diode in this case? Normally we are saying no, only the 0.7 volt is the drop across the diode. But in this case, what is the drop across the diode? If it is asked, this is the V is the drop across the diode. So what is the V here? 10 minus I. What is the value of the I? 18.6. Sorry, what is the I? 6.2. 10 minus 6.2. What is the value of the I? 3.8. The drop across the diode is not 0.7 guys. It is 3.8 volt. Very, very high voltage across the diode. Okay, 3.8 volt is the drop across the diode. That is the case. Now, is there any other method to solve this question? Any other method to solve this question? Yes. There is another method. I am going to solve this. Okay. What is the method then? Guys, now watch this. This is a V minus 0.7 divided by A. Okay. From this equation, yesterday I have given you the idea that piecewise linear model. Piecewise linear model means we are having some cut-in voltage at this point and the graph is like this. And then this will follow this line. Okay. Then this is called V gamma. So what is the V cut-in voltage in the question is given. If it is 0.7, it is 0.7 greater than 0.7, then it will follow this equation. And this is the I here and this is the V here. Okay. That will follow the right. This is the equation of line guys. This is the equation of line. So what is the equation of line? I is equal to V by 500 minus 0.7 divided by 500, right? And compare with this, y is equal to mx plus c. So what is the slope of this line? This is the x is what v, y is what I. So what is the slope of the line? You can say the slope is what? 1 by 500. 1 by 500. And what is the slope of this line? Yesterday I have given. What is the slope of this line? 1 by RF. And this is the 1 by 500. So you can get the value of the RF. What is the value of the RF? 500 ohm. What is the value of the RF? 500 ohm. And this is what? 0.7 is the cut-in voltage. Then, if this is the case, if the diode is forward biased, it is called piecewise linear model, then you can replace the diode by 0.7 volt, that is the cut-in voltage, and 500 ohm as a RF. Or normally we are converting it into what? Kilo ohm. 0.5 kilo ohm, and that is what? 0.7. Now in this question, in the given question, if we are going to replace the diode 10 volt, and by using that you will get the very, very easy answer. 10 volt, this is 1 kilo ohm. The diode is replaced by 0.7 and the one resistance, right? This is the 0.7, this is the 0.5 kilo ohm, this is the 1 kilo ohm, this is the 10, and then directly you can find the value of I. 10 minus 0.7 divided by 1.5. 9.3 divided by 1.5. Calculate it, you will get the answer 6.2 milliampere. 6.2 milliampere. So this is nothing but piecewise linear model, guys. This is another approach to solve this particular question. So which one is easy for you? First one or second one? First method or second method? This is the first method. And that is the second method. Piecewise linear model. It's up to you. Okay. Again, if you want to find the drop across the diode, remember guys, this is the complete diode. So this is the drop across the diode. So what is the total drop across the diode? VD will become 0.7 plus I into 0.5. 0.7 plus I, what is the I? 6.2 into what? 0.5, that has become 3.1, and you will get the answer 3.8 volt. 3.8 volt. In previous case, again we have get the 3.8 volt, that is the drop across the diode. Okay, next. अब देखो क्या होगा पता है, आप एक क्वेश्चन को मल्टीपल तरीके से बनाने की कोशिश कीजिए, बिकॉज इन दिस वे वी कैन प्रैक्टिस द मेथड्स and in exam hall we can decide, because in exam hall we can't use the multiple methods. You have to choose one method and very quickly we have to decide which method is suitable to solve the question during exam. But you have to practice, try to solve the question, particular question with all the methods, one method, two method, three methods, and what is the answer. Now next question, give me the answer for this one. Okay, tell me. Now, assume that the diode in the figure has V on is equal to 0.7 volt. Otherwise, it is ideal. Means, what is the internal resistance of the diode? 0. The magnitude of the current I2. What is the magnitude of the current I2? Okay, tell me. In this question, you have to find the current. 2 volt battery is connected here. It is connected to the positive terminal of the diode, but what about the diode, whether it is a forward bias or reverse bias? How we can check? And minimum 0.7 volt is required to make it what? Forward bias, because it is a practical diode. Minimum 0.7 volt drop across the diode is required to make it forward bias, and then what? 6 kilo ohm. So this is the current and you have to find the I2. In this type of questions, first of all, always consider that let the diode is reverse bias. If the diode is reverse bias, then what about the diagram? Let the diode is reverse bias. If you are assuming that the diode is reverse bias, means diode will act as open circuit. And this is the 2 volt battery. Now, this is the 2 kilo ohm, this is the 6 kilo ohm, this is the 2 volt battery. Okay, find the current. When I am going to find the current, it will become 2 divided by 6 plus 2, 8. 1 by 4 milliampere. 1 by 4 milliampere, guys. Now, if it is a 1 by 4 milliampere, okay, then find the drop across this 2 kilo ohm resistor. Because the current enter like this. So, what is the drop across this resistor? V1. You can find a V1 is equal to I into 2. And I into 2 means 1 by 4 into 2 kilo ohm. Milli is cancelled with the kilo. You will get 1 by 2 volt. 1 by 2 volt means what? 0.5 volt. 0.5 volt. Now, this is the voltage across the diode, because the diode is connected parallel to this one. What is the drop across the diode? 0.5 volt. And what about the remaining drop across the 1.5 volt is across the resistor. Guys, and it is required minimum 0.7 volt, and we are having only the 0.5 volt, and that's why it will remain off. It will remain off, and that's why what is the answer for the current? 1 by 4 milliampere. Diode is not in conduction. Diode is not in conduction. That is a simple diode circuit, guys. So first of all, always check whether the diode is forward bias or reverse bias. Okay. Okay then. Now, tell me. Is it clear, guys, everyone? So Subhankar, Nandita, and all other Shailaja, this question is clear to you. Very simple one. Now, we will solve one more question on that diode circuit. That is a simple diode circuit, and how we can get. Always remember, if it is not, in this case, directly we can't consider that whether the diode is forward bias or reverse bias. First of all, choose the reverse bias, then take the voltage across the diode. If it is greater than 0.7, the diode is forward bias. Otherwise, guys, it will remain off, and the I2 is what? 1 by 4 milliampere, that is 0.25 milliampere. Now, next question. no, this is a multiple diode circuit, guys. Then in this case, the input voltage Vi to the two level clipper, this is the clipper circuit, but directly varies linearly from 0 to 150 volt. But what is asked here? Maximum and minimum output voltage only. What is the maximum output voltage and what is the minimum output voltage? Then maximum means when we are choosing the 150 volt as an input, you are going to get the maximum. Minimum means when we are going to put the 0 volt as an input, then you will get the minimum voltage. So when there are two cases, 0 and 150, then what will be the answer? For example, first of all, I am choosing 0 volt. Short circuit it. Vi is 0 volt. When the Vi is 0 volt, now watch this diagram carefully. Because of this 100 volt, always watch what is the highest battery in the circuit. There are two diodes. Because of this 100 volt, definitely it is only 25 volt, it is 100 volt, definitely diode D1 is off. Why D1 is off? Because it is reverse biased by the 100 volt. Now once it is off 100 volt, remove the 100 volt battery, it is out of the circuit. Now it is a 25 volt, it will also reverse bias the D2, the D2 is off. Because already we have removed the 100 volt battery, now because of that D2, it is also connected to the negative terminal, here voltage is 0, this is also off. If both the diodes are off, what will be the output voltage in that case? This is a 10. This diode is off. This diode is off. And there is no current through the resistor and the output will become 25 volt. Output will become 25 volt. This is the minimum output voltage. Minimum output voltage. And remember, our assumptions is correct. Why our assumptions is correct? Which question, Abhi? You want which question to solve with the 1 kilo ohm? Okay, that is the same question, previous one. Okay, I will solve that. Okay, no problem. Now, this is a 25 volt is the output voltage. If the input voltage is 0 volt. And definitely, it is a 25 means at this 25. And what is the voltage that, what is the current through this resistor? 0. Check that on the D2, on the negative side you have 25 volt, on the positive side you have the 0 volt, that is our assumptions is correct. Check the D1. On the D1, on the negative side you have 100 volt, on the positive side you have the 0 volt, again the D1 is off. So our assumptions is correct. When we are assuming that let the diode is reverse bias, always at the end check Vp should be less than Vn. Vp should be less than Vn. Yes, I will solve. Abhi, 1 minute. After this question, I will solve. Okay. So that is the minimum voltage is 25 volt. What is the maximum voltage? Maximum voltage, when you want to find, put the maximum value of the input. What is the maximum value of the input? 150 volt. 150 volt. Suppose this is the 150 volt. Guys, 150 volt, this is greater than for this diode because it is greater than 100 volt. And greater than 25 volt, so we can assume that both the diodes are on. And always remember, if we are assuming that let both the diodes are on, then current should be positive and current should flow from P side to N side. We will verify it. When the diodes are on, it will act as short circuit. This will act as short circuit, this will act as short circuit. So what is the voltage at this point? 100 volt. What is the voltage at this point? 100 volt, and output will become 100 volt. This is the maximum voltage. This is the maximum voltage. You can't give the direct answer 100 volt. You have to check whether the current is positive or negative. For example, this is no doubt 100 volt. Let this is the current, incoming current. What is the current we can solve? Let this is the I current. Okay, this is the I current. Then you can, if you have to find what is the current through this one, this diode, you can apply the KCL at this point because we have the voltage 100 volt. So what is the case? 100 minus 150. 100 minus 150. I am applying the KCL at this point. 100 minus 150 divided by 100 plus 100 minus 25 divided by 200 plus I, because I is also outgoing current. I am taking the outgoing current I1 plus I plus I2. What is the I1? 100 minus 150 divided by 100, 100 minus 25 divided by 200 and plus I. Then you can take 200 as a LCM. It will become what? 200 as a LCM, then it will become 200 minus 300 plus 100 minus 25 plus 200I is equal to 0. And then you can verify 200 plus 300 cancel out. And then what is the I? 25 divided by 200. Check my calculation. 1 by 8. 1 by 8 milliampere. And guys, this current is positive. If this current is positive, means that diode is forward biased, because it will flow from P side to N side. And then what is the I2? What is the current through the D2? 100 minus 25 by 200. Definitely it is positive. 100 minus 25 divided by 200. No need to check. It is greater than 0. So both the currents are greater than 0. That's why our assumptions is correct and both the diodes are on. Right? Both the diodes are on. Right? Okay? That is clear to you. Okay. I think now it is clear. You have checked. So abhi you have solved the question. Yes. Now I will solve for 6 kilo ohm now. So this is the answer. What is the minimum value? 25 volt. What is the maximum value? 100 volt. Maximum 100 volt. Minimum 25 volt. This is called multi-diode questions. In next class, when I am going to solve what previous year questions, we will discuss multi-diodes question. And in this 2023, very important questions on 3 diodes. What about the diode condition? D1, D2, D3, which are on, which are off. So we will discuss those questions, and tomorrow we will discuss the digital at the same time. Digital. So what was the question? What is your doubt? Now in this question, what you want to ask? Again, suppose you are taking the 1 kilo ohm, again the diode will remain off. Again the diode will remain off. For example, it is 1 kilo ohm. 6 kilo ohm. This is the 2 volt. So what is the drop across the 1 kilo ohm resistor? According to voltage division rule, V1 will become 2 into 1 divided by 7. 6 plus 1, 7. 2 by 7. And 2 by 7 is less than what? 0.7. 2 by 7 is less than 0.7, and that's why the diode will remain off. Directly you can find the current. If you are taking the 6 kilo ohm, for example, if you are taking the 6 kilo ohm, like this is 6 kilo ohm, this is 6 kilo ohm. Initially you are assuming that the diode is reverse bias. So what is the drop here? 6 kilo ohm means drop is 1 volt. And remember guys, the 1 volt is greater than 0.7 volt. That's why diode is not reverse bias. Diode is forward bias. Diode is what? Forward bias. Then what is the value of the current? You can't say, sir, value of the current in this case will become 2 divided by 12 kilo ohm. No. That is what? 1 by 6 milliampere. No. Because in this case, the diode is on. Once the diode is on, you have to redraw the diagram. What is the diagram then? Once the diode is on, this is the 6 kilo ohm. Just I am assuming that this is the 6 kilo ohm. With new question, 6 kilo ohm. In case of 6 kilo ohm, that diode is on. And what is the drop across the diode? 0.7. 7 volt, it is fixed. 6 kilo ohm, this is the 6 kilo ohm. Right? Now, and you have to find the I2. I2. Then it is the 2 volt, it is 0.7 volt. So what is the voltage at this point? 1.3 volt. 2 minus 0.7, 1.3 divided by 6. That is the value of the I2. 1.3 divided by 6, that is the value of the I2 you can find. So abhi it is clear to you everyone, that concept is clear. So if the diode, first of all, always check that the diode is off, and what is the voltage across the diode. If it is greater than 0.7, diode is on. If it is less than 0.7, diode remain off. Once it is on, it is converted into a battery of 0.7 volt, and then you can find the current here. You can find the current here, I2. Okay. They may ask another question, they may ask what is the power dissipation across the diode. In that case, you have to find the current here. You have to find the current here. What is the current here? I2. What is the current here? I1. This is the I2. This is the I1. This is the I3, because it is the I2. I1 plus I3 is equal to I2. And you have the idea about the I3, 1.3 divided by 6. Then you can find the current through this. Our I1 plus I2 is equal to I3. First equation. That is nothing but 1.3 divided by 6. I1 is the current through the diode. So what is the value of the I1? I2 minus I3. And what is the I3? 0.7 divided by 6. 0.7 divided by 6. So what is the I1 will become? I2 minus I3. 1.3 divided by 6 minus 0.7 divided by 6. 1.3 minus 0.6 is what? 0.6 divided by 6, that is become 0.1 milliampere. 0.1 milliampere is the current through the, 0.1 milliampere is what? Current through the diode. If the 0.1 milliampere is the current through the diode, then what is the 0.7? Multiplied it and you will get the power dissipation. So what is the power dissipation across the diode? The drop across the diode and current through the diode. 0.7 into 0.1. 0.07 milliwatt. Why milliwatt? Because this current is in milliwatt. Because this current is in milliwatt. Check my calculation. That is the method. In this way we can solve any type of questions. Whether the power dissipation is asked, or what is the current through the diode, what is the current through this resistor, what is the current through that resistor. Always remember, if the diode is connected, there may be the two possibilities. It may be on or it may be off. In every case you have to verify. Suppose you are assuming that let it is on, then finally calculate the current through the diode, and from P side to N side that current should be what? Positive. That current should be positive. Okay. So I think now you have got the idea. So how are you, Dave? So what about your preparation, guys? Everyone going fine? ISRO examination. So tomorrow I want to give you the information, then I am concluding the session. Tomorrow we have one session at 11 AM where we will solve 10 questions. This is the quiz actually. 10 question quiz on analog with the description, guys. I will give the answer for all the questions at the end. In starting 30 minutes, I will give you chance to solve the questions, and in next 30 minutes, I will give the answer for these questions. Okay. So that is the analog 10 questions, or 11 AM on BYJU'S exam prep app. On app, this is the class. So install the BYJU'S exam prep app and join. And tomorrow sharp at 7 PM again on YouTube, we will discuss digital's basics. And for more detail, very simple, join my Telegram channel, that is Electronics by Sanjay Rathi, so that you will get the notification for all my session, guys. And you can also put your queries, right? अगर आपको कोई doubt है या इस screen में कोई question समझ नहीं आया, then take a screenshot of that question and please post there. I will try to give the answer for those questions. Okay, then thank you for attending the session. You are on BYJU'S exam prep. Like the session, share the link of this session and subscribe our channel, guys. And finally, scan this code to subscribe this channel. Okay, then thank you and good day.